All right, so we're going to look at defining an average rate of change today. We talked a little bit about this in Unit 1, but we're going to kind of formalize that today and talk about it in terms of calculus speak. So when we talk about slope, we talk about an average rate of change, and we know that the slope formula is y2 minus y1 over x2 minus x1. And in calculus, it's usually referred this way: f of x2 minus f of x1. Those are just your y2s and your y1s, all over x2 minus x1. And in calculus, we'll also express this in a slightly different way. We know that from algebra that the slope is the change in y over the change in x, and we're going to define that using these symbols. We're going to say this little triangle symbol is a delta symbol, so we're going to call this delta y over delta x. We can also write that like this. You'll see it written as, this is a more common notation, dy dx. Again, simply means the change in y over the change in x, so the slope. And we're also going to see it written like this, f prime of x. So these two notations are the most common in this class, dy dx and f prime of x. But you may also see it, as I realize, you may also see it written like this at times, y prime. So f prime of x just means the slope of the function f at a particular value of x. All right? And so today we're mainly going to look at average rates of change. We'll come back and actually define the derivative in our next lesson. So if I want to find the average rate of change over the interval 0 to 30 using this t-table, I'm going to do exactly what you've been doing for years and years since Algebra 1. We're going to do the y2 minus y1, but I'm going to write it a little bit differently. I'm going to call it f of 30 minus f of 0. So that's my y2 minus y1 over x2, which is 7, x2 is 30. 30 minus 0. And you just need to be familiar with this notation here. Now, obviously, the value of f of 30 comes out of my table. This is f of 30 here. This is f of 0 here in the table. So I would simply do 7 take away 3 all over 30 minus 0. And that's going to turn out to be 4 over 30. And you can simplify that if you want. This turns out to be 2/15. So that is the average rate of change, or the slope, from 0 to 30 given this t-table right here. We can do this with an equation as well. If we have an equation, we're just going to need to do a little bit of extra work first. So my interval, it says find the average rate of change over the interval from -1 to 3, given the equation g of x equals -x squared plus 3x. So if I'm going to do this, first thing I need to do is I need to find f of 3 minus f of -1 all over 3 minus -1. So that's the first thing I need to do. So that means I'm actually going to go ahead and plug those values in, 3 and -1, into my function. And actually, in this case, you know what, I just realized this is actually a g function, so I'm going to change these to g of 3 and g of -1. I'm so used to f. So I need to find g of 3. So I'm just going to come over here. I'm going to plug in 3. G of 3 is equal to -3 squared plus 3 times 3. So that's going to be -9 plus 9. So I'm actually going to get 0 there. Then I need to do g of -1. So we'll do the same thing. That's going to be -1 squared plus 3 times -1, and that's going to end up being -1 minus 3, which is -4, And now I can go back and plug those values into my formula. So I'm going to do 0 minus -4. And the denominator, I can go ahead and change those. That's going to be 4. And so that's going to be 4 over 4. So the slope in there is simply 1. Now, when we go to interpret a derivative, we want to be able to say, you know, what does that derivative mean? A derivative is a slope, okay? And so when we look at something like a fraction, these numbers in calculus tend to have units attached to them. So it might be miles per hour or something like that. In this case, we're talking about a function. F of x represents how many meters you have run, and x represents the number of minutes. Describe the following. So we've talked about this first one. What does f of 8 equal to 1500 mean? Well, in order to interpret this, we need to understand that, number one, x represents the number of minutes, and f of x represents how many meters you've run. So if you think about this, when I look at this statement right here, f of 8 equals 1500, 8 represents the number of minutes, so I could say in 8 minutes, let's see, and the y value represents, here we'll just do this, this is x, this is y, and the y value represents how many meters you have run. So in 8 minutes, I ran 1500 meters. Pretty standard notation there. We've talked about some of that already, but the next one is our new notation here. You'll notice it doesn't say f of 3, it says f prime of 3. Okay, so again, f prime, okay, so if it's just f prime of x or f prime of anything, f prime is, we call that the derivative. The derivative, and when we say the derivative, we basically mean the slope. So f prime of x is the derivative of f of x. So when it says f prime of 3, I'm talking about the fact that, again, this is still x right here, but this is, the 161 represents the derivative value. So I could still say at 3 minutes, so at 3 minutes, the 161 represents my rate of change. That's what f prime is. It's a rate of change. It's a slope, okay? So at 3 minutes, I was running 161 meters per minute. Because remember, slopes have units on the top and units on the bottom. When we did our average rate of change in the previous problem, I could have said that these units up here were meters per minute or meters per hour, whatever it was, meters per minute. And so the y values represent meters, the x values represent minutes, so this could have been 1 meter per minute. So we'll talk a lot more about derivatives tomorrow. We'll define some more of those as well. Have fun with that one.